Hello everyone, welcome to mentorbuddy.com. This is your mentor Gurvansh, and now we are going to see the second part of EDA and data preprocessing, where I will show you how do we actually perform these steps in a Python program. So guys, as you remember from the last video, we first start by importing the libraries in the Python program. Now we are importing the libraries. So the libraries which we are going to use over here is the numpy library. So we write import numpy as np. So here we are using the as keyword to reduce our numpy name to np. Then we are importing the pandas library, and we are going to import, we generally use the matplotlib library, but in the data pre-processing step we do not actually need it because we are not going to import any of the plots. Okay, matplotlib.pyplot. Now the matplotlib is a very big library, and from the whole matplotlib library we are using the python plot. So we specify the module which we are using, which is the pyplot module. Now after the libraries are written, means whichever library you are importing, we press shift and enter to run this cell. Now the Jupyter IDE, Jupyter Notebook IDE, which I am using right now, is a cell based IDE where we can write separate codes in separate cells and run them whenever we need them. Right now, after we are done importing the libraries, our next job, or the most immediate job, is to import the dataset. So here next we will be importing the dataset in our code, right? So for this we need the pandas library, and when we import anything, any variable, any value in our Python code, we need a variable to store it. That is why I am defining df as the variable. So here I'm going to write pd is the pandas library name dot read underscore csv. So the file type which I am using here is the CSV file. Now the file which I am using over here is the data.csv. This is the file. The dataset here I am using is a bit smaller. The reason for keeping the dataset smaller is that whenever I will use any technique, you will be able to immediately understand, okay, this is happening. If I use a very big data set, it will become much more confusing and much more harder to identify what exactly is happening in the dataset. Now what this CSV means, CSV means the comma separated values. When the column values are separated by a comma, it is known as comma separated values. So to import a dataset, here we need to name in the single inverted quotes we write the name of the file and its extension. Both of them are necessary to import the dataset. Then I will print the variable. So I am printing df, which is the data frame. When I run this particular cell, as you guys can see, the dataset has been imported with all the 4 columns, and they are neatly arranged as columns, not like this in the comma format. Now here we have country column, age column, salary column, and the purchased column. As soon as we get this particular dataset, we will start with our EDA. Generally the datasets are pretty big, so we need to perform those steps to actually know about the data pre-processing step. Here the dataset, since it is very small, we already know that this is the string value. We have missing values over here, we have different feature scaling, but generally the dataset is very big, and we do not have actual time to go through all the rows and the columns, all the cells, to know which data pre-processing steps we need. So here we will start with our EDA. Now guys, this Jupyter notebook has 2 types of cell, code cell and the markdown cell. Markdown cell is used to create headings like this, and the code cell is used to write the actual code. So here I will be writing with a single hash sign EDA, and the full form of EDA is exploratory data analysis, where I am trying to analyze my data in order to know the data pre-processing step. How do we start? We start by getting the complete info of my data frame. So I am writing df.info. This is a pandas library function which is going to give you the complete information of your data frame, which is df. So here is the complete information. It is saying that it is the df. What is df? Df is a pandas core data frame. What is the range index? So this is the row index, which is 10 entries, 0 to 9. Then it says it has data columns. 4 columns are present. What are the column indexes? First is 0, 1, 2, 3. Name of the columns are country, age, salary, purchased. How many non-null value it have? It is essentially telling you whether there is a missing value or not. So you'll have to compare a bit. Total entries are 10. Here it says in country column there are 10 non-null value, means all of the values are present. In age column there are 9 non-null values, means one missing value is there. In the salary column also we have one missing values, and in purchase column we have 0 missing values. Then it is showing you the data type of all the particular columns respectively. The string column or the categorical columns are identified as object type in the pandas frame. So it says that total data types for float we have 2, for the object we have 2. Now guys, there is another method to find out the missing values in the pandas data frame. For that we use the combination of different functions. So we write print df dot isNA. IsNA is a function which is used to know whether the value is missing or not. Then we apply the sum function on it to take a collection of all the missing values in the respective columns. When you run this cell, you will get country column has 0 missing values, age column has 1 missing value, salary has 1 missing value, purchase has 1 missing value. What is this D type? This D type is showing you the output of this combination. This 0, 1, 1, 0 are the integer value, that is why it is showing you the int 64 output. Then guys, we can now, as you are seeing over here with the pandas data frame, sometimes the data set is very big, right? So we can use this particular head and tail functions of the pandas data frame. Pandas library head function will give you the headings and the few starting rows of a data frame. In the same way, when you write print df.tail, it is going to give you the tail part of any data frame, meaning the last rows of the data frame which you have. Then guys, we can, okay, now let me tell you how do we actually access all of these columns separately. To access any column in a data frame, you need to write the name of the data frame. Sorry, you need to write the name of the columns. Now let's say I want to take the mean of the age column, right? So what I will do, I'll write print df in the square bracket, in single inverted quotes we will write the name of the column, then we will write dot mean, close the bracket, and run this cell. So the mean of this particular age column is 38.77. The same way I can take the median also for age column and the salary column. So let me show you the median for the salary column. So if I write print df in the square bracket, I am going to write salary dot median, closing the bracket, running it. So the median of the salary column is 61,000. Now guys, we have a function for the pandas library which can help you to check whether the categorical values or whether the names written over here are correct or not. How we do it and why we do it. Let me first of all show you the function. So we have print df dot, sorry, df in the square bracket, we are going to write the name of the column. So the name of the column is country, right? COUN, and we can use the tab key of the keyboard to autofill it. Dot, so the function name is value counts, and I am using the tab key of the keyboard to try to autofill it. When you will use tab, it will show you which function you can apply. So I am applying the value counts function on my df country column, and when I run it, It will tell me that France has occurred, France is repeated 4 times, Germany is repeated 3 times, Spain is repeated 3 times. Total is 10, right? And we also had 10 entries in our particular column. Now, if let's say by mistake, instead of writing France completely, I wrote France, there is a mistake. Now that mistake will be highlighted as 1. So we will have another complete value. So there will be France 3, Germany 3, Spain 3 and France 1, which is wrong. So here you can know that okay, this value is wrong, we need to alter it, right? Now with this data preprocessing or EDA, we know that we have the categorical columns, right? We have the object column, so we have to perform the encoding. We have the missing values, so we need to take the care of the missing values. We have different scaling in our data, so we'll have to perform feature scaling. Now there is one question about X and Y and the splitting of the data set, right? Talking about that, with the let's talk about the problem statement. So the problem statement over here is that your company has created a product. They have launched the product in the country all over the world, and they are seeing whether someone is buying their product or not. You have collected the data from the customers, asking them their country, their age, their salary, and whether they have purchased the product or not. Now you have to create an algorithm in such a way which is able to identify whether another person of the same category will buy the product or not. Now with this problem statement, we know that this is a supervised learning algorithm where we have the X and the Y. Since we know it is a supervised learning algorithm, we need to first of all split our X and Y, and in the last step we need to break our X and Y into training set and the test set to make this algorithm work. Now we will be moving on with our data pre-processing steps. So here I am writing data pre-processing. Yes, now as I've told you, what is our first task? Our first task is to take the X and Y, to extract the X and Y from our original data set. So here I am writing X is equal to df dot. Now pandas provides us with another function which helps us to access our rows and columns using their index number itself. Now if you remember earlier, I was using the name of the columns. Now imagine you have 20 columns. How can you write the name of the 20 columns one by one, remembering the names, writing them to create your X, right? So in order to avoid that, we have the ilog function. So ilog function has two parts which is separated by a comma. Left to the comma we give the row indexes, right to the comma we give the column indexes. So as for the rows, we need all the rows, so we just give the colon sign identifying or indicating that we need all the rows. As for the columns, we need all the columns except the last columns, and as you know, the last column in Python is the last element in any data structure in Python is identified by -1. Now to extract the values, we need the values function. Why? Because we are actually extracting the values from the data frame. In the same way, I'm going to write y is equal to df.ilog all the rows, comma, this time only the -1 column dot values, right? Let me print the X and Y to show you how they look after we have extracted them. So here is our X column, sorry, X array, and here is our Y array, which is France now, age column and the salary column in X and the purchased column in Y. Now once our X and Y have been extracted, our next step, if we have to do, is imputing the missing values. Now guys, I have told you that I will explain what exactly happens in missing values. Now while taking care of the missing values, we can do two things, right? Taking care of the missing values, we can take two steps. First step is removing the row having the missing value. Second is replacing or imputing. The technical term is imputing. Replacing slash imputing the missing values with more common values. Common values like mean of the column, mean or the median of the column, or median of the column. For this, guys, see, when we try to remove the row, we have a good chance of losing information. So we actually do not use the first step. We always try to impute the missing values. For this step, we need the scikit-learn library. So from here on, we will need the scikit-learn library, which is the library specially designed for the machine learning algorithm. So here we are trying to impute the missing values using the scikit-learn library. So here I am going to write from sklearn, again using the tab to autofill it, dot impute. Impute is the module which we are using over here. Then we write from sklearn dot module. Sklearn is the library, or scikit-learn is the library. Impute is the module. We write import simple imputer. Simple imputer is the class which we are going to use over here. Whenever we import a class, we need to create the object of the class. So here I am writing the name of the object is imputer. Then while creating this particular object, we need to mention the parameters which we are going to use. So essentially we use two parameters. First is how we are going to find the missing values. Second is with what strategy we are using to impute those missing values. So here the first parameter is missing values. For finding the missing values, I am using np.nan methodology. Why NP? NP because this particular x is a numpy array. So if you look over here in the variable inspector, this tells you the data type. It is a n-dimensional array, ND array. X is an ND array, Y is an ND array, meaning that they are numpy arrays. DF was the data frame. So NP identifies numpy and NaN identifies these values. See, np.nan, right? Then after the comma, we write what strategy are you deploying to impute the missing values. Here the strategy I am using is mean. So my missing values will be replaced by mean. Then guys, we use this imputer function of the simple imputer class which we created, and use the function, an inbuilt function which is fit transform, to fit the original data and then transform the original data. Here we mention on which column are you applying. So we are applying on X, and specifically we are applying on the first and the second column. So to mention the first and the second column, so 0th country column is the 0th column, age is the age column index is 1, salary column index is 2. So to mention this, we write 1, 2, 3. As you all know, in pandas, in range, the last or the upper index number is not included. So here it will be applied on 1 and 2. When we fit and transform the data, we store the transform data in the same area. So here also I am going to mention comma 1, 2, 3. You have to mention both exactly the same value which you are mentioning in this bracket. You have to mention the same value over here to impute the missing values. Then let me print it and show you what exactly the output is. So if you look over here, this particular NaN is replaced by the mean of that column, which is 63,777, and this missing value is replaced by 38.77. Okay, so this is how we have taken care of the missing values by imputing them. Next job which we do over here is to encode our categorical data. Now we will be encoding the categorical data. So to encode the categorical data, first of all, let me give you an explanation on how it is done. So let's say I have this particular data. I have this column, right? Country column. me increase the size. We have country column. In this country column we have, let's say, France, Spain, Germany, Spain, Germany, France, France, right? I'm just taking an example. So here we use two different classes now. We use first column transformer class and then we use the encoder. I will tell you the reason why we do it. Encoder. So the job of the column transformer is to convert these categories into their respective columns. So after applying column transformer on this country column, we will get this output. So we will get France as a column, Germany as a column, and Spain as a column in alphabetical order. Now what will this encoder do? What is the name of the encoder we are using? We are using one hot encoder. Now this one hot encoder is used to fill the values. So wherever it will find the matching values, it will put 1, otherwise it will put 0. So for the first row we will get 1 in the France column, then 0 0. For the second column we will get second row we will get 0 0 1. For the Germany row we will get 0 1 0. Then for the Spain we will get 0 0 1, then 0 1 0, 1 0 0 and 1 0 0. Now here these encoded columns are known as the dummy variables. So the encoded column, the numeric column which we create after encoding the categorical values, are known as the dummy variables, and we perform this binary encoding. This is also known as binary encoding on X. So let me tell you how do we actually achieve it. So here also we will need the scikit-learn library. Okay, so first of all we are going to import our two classes. What were the two classes? First class was the one hot encoder class, second class was the simple imputer class, right? So here I'm going to write from sklearn. Now guys, both of these two classes are in two different modules, so we need to import them separately one by one. Okay, so we write from sklearn dot compose import column transformer, COLUM, column transformer. Then we write from sklearn dot preprocessing import one hot encoder. Then we create the object of the column transformer using one hot encoder as a value. So we write CT is a very small, I am using very small object name over here. We write column transformer. Here we use two parameters again, transformers parameter and remainder parameter. So we write transformers is equal to, it is a list of the values which we are going to use now. So here I am saying that what values are actually transforming the data. So I say that I am using an encoder. What is the name of the encoder? I am using the one hot encoder. And on which column I am applying it? I am applying this on the 0th column. So this is what are the three values, how you are transforming and what you are transforming. To transform, I am using the encoder, the name specifically I am using the one hot encoder, and what I am trying to transform, I am trying to transform the 0th column of X. Then the next question is, what about the remaining value? For the remaining value I say just pass through, do not do anything to it, just pass through. Then we write X is equal to CT dot fit transform. I am actually using again fit transform to change my data, then X, then I'll write print X. When you run this, you get this particular output, the same which we saw in the PPT. Here we have gotten the encoded columns. So this is how we perform encoding on X. Now to do the same thing for Y, as you have seen before, Y is also the categorical data, so we need to perform the encoding on Y also. To do this, in Y, keep this in mind guys, in Y we can only have one column, no extra columns are allowed. So in Y we are going to use from sklearn dot preprocessing import label encoder. Now we create the object of it, LE label encoder. Here we do not mention any parameter. The reason is because we already know that in Y we have one column and that one column needs to be encoded. So we just write Y is equal to LE dot fit transform. Then we write over here Y and then let's print Y. So when you print Y now, again you will get the ones and zeros value. So this is how the encoding part is done. Once the encoding is done, we need to first take care of the feature scaling. Then we will split our X and Y into training and test data. So how does this feature scaling work? Let me give you a very small mathematical formulation for that. Now let's say we have the salary column, right? We have age column. So let's say we have 40 over here, we have 60 over here, age, and let's say we have 50 over here. So these three, I'm just taking a very small example. And exactly as at the salary column, let's say I have the salary of 70,000. Then let's say I have the salary of 60,000. Okay, 60,000. And let's say I have the salary of 50,000. Now how we are going to bring them on the same scale? Now to bring them on the same scale, what the easiest formulation which we can use is that we can divide all of these values xi by their mean x bar. So we can do the same over here also, xi divided by x bar. So what is bar? X bar is the mean of the column. So when you take the mean of the column, we will add 40 plus 60 is 100 plus 50 is 150 divided by 3 will become 50, right? 40 plus 60 is 100 plus 50 is 150 divided by 3 becomes total mean is 50. So what we can do over here, we will do 40 divided by 50 comma 60 divided by 50 comma 50 divided by 50, right? In the same way we are going to do the same thing for the salary column. So we do 70,000 plus 60,000 plus 50,000, we get 1,80,000 divided by 3, we are going to get 60,000 as the output. Now here you can write 70,000 divided by 60,000, sorry, 70,000 divided by 60,000. Same goes 60,000 divided by 60,000. I am removing the zeros, okay? 50,000 divided by 60,000. Now once you get the output, of it, so 40 divided by 50 will be 0.8, 60 divided by 50 will be 1.2, 50 divided by 50 will be 1. Here 70,000 divided by 60,000 will be 1.17, 60,000 divided by 60,000 will be 1, 50,000 divided by 60,000 will be 0.83. Now as you guys can see over here, the output of it has now both of the columns, the age column and the salary column, has been reduced to a very similar scale. Both of them, the values are from 0 till 2, you can say that. So this is how it is done. This is just a normal, very easy formulation to reduce the scale of any column. Here we are going to use the standard scalar class, which is a more powerful class, standard scalar class, and it uses this formula, xi minus x bar divided by the sigma. So xi are the respective values 1, 2, 3 and so on. X bar is the mean of the column and sigma is the standard deviation. Now showing this formula will be much more mathematically difficult over here, so that is why I used a simpler formulation for the same thing. So here, coming back to my Jupyter notebook, what we use, we write from sklearn dot preprocessing import standard scalar class, and here I write sc is equal to standard scalar. Now since the formula is already fit, the formula is already there, we just write x is equal to sc dot fit transform x, and then we are going to print it. Now guys, the output of this particular class is in scientific notation, and we do not need to panic about it. It is automatically processed. We do not need to do anything. Once our feature scaling is done, since it is a part of supervised learning, we just separate it into training set and test set. To do this, we write from sklearn.model-selection import train test split. Now this is a function. Till now we were importing classes to do our job. Now this time we are importing a function to do our job. Now what this function does is that this function splits our x and y into training set and test set while shuffling the rows. Now there is a little bit trick over here. The trick is that this function randomly shuffles the rows and column. So every time you rerun a code, it will randomly shuffle it. To avoid that problem of random reshuffling, we put a seed value in it and use the random state parameter to set a seed value, so that whenever you rerun the code, your shuffling will remain the same. So this particular function gives us 4 output in the sequence which I am showing you right now. So it gives you xtrain data, comma, xtest data, comma, ytrain data, comma, ytest data. This is the permanent sequence which does not change, equal to, we write train test split. It takes 4 inputs, x, obviously x and y, 2 inputs. Third input is the training size. So you can write train or the test size, you can give any value. So test size I am giving, test size is equal to 0.2 or 20%. For this case I am using 20% for the test size. Why? Because we have 10 rows, and if I divide it into 7.5, 2.5, it will not work, give you an error. So we are dividing it into 80-20 ratio. 8 rows will be taken as training xtrain and 2 rows will be taken as xtest. Then as I have told you, we use the random state parameter to set a seed so that our shuffling is the same every time we rerun the code. Very simple line, and our x and y will be split into training and test data. Then let me print it and show it to you. So we write print xtrain, print ytrain. Now the x and the y values which I am printing right now are the corresponding values. So for the corresponding row we have the corresponding x row, we have the corresponding y row. So 8 rows are here right now with the corresponding values, and then we can print the x test and their corresponding y test value. Print y test. Run it. So here we got the 2 y test value. Now guys, with this the data pre-processing steps are done. Once the data pre-processing and EDA steps are done, we can start with our actual ML algorithm, train it if it is a part of supervised learning, test it, and then visualize the output whatever we get. Thank you guys for joining us on Mentor Buddy, and I hope that you learn how to actually perform these data pre-processing steps in the Python programming language. Thank you guys for joining us.